So let's talk about the last part of chapter 15. Everybody's doing so good with turning in, taking the quiz and turning in homeworks and everything. So just keep it up. We're almost done with this chapter actually, and your test will still be on Monday. So first online test will be on Monday coming up. All right, so let's talk about Le Chatelier's principle. So Le Chatelier's principle says that if a system is at equilibrium, so if I'm at equilibrium and the conditions are changed, so I'm at equilibrium and I do something. So if a system is at equilibrium and the conditions are changed so that I'm no longer at equilibrium, the system will react to reach a new equilibrium that will counteract this change. So it's at equilibrium, I do something, and now it has to shift to readjust. Okay? A system that's at equilibrium doesn't want to change, so it's going to resist this change. And so we're going to kind of get like, if pushed, it's going to kind of push back idea. All right, and so there's a bunch of different things that I can do to the reaction that's going to cause a shift one way or another, and maybe no shift at all. And these are called stressors, and we're going to talk about each one of these. This is kind of like a little summary chart of all the stressors. So I can apply a stress to the system, and it's going to cause a shift. It's either going to shift to the products, to the reactants, or other things. Maybe no shift at all. All right. So let's look at the first one. The first thing is going to be on concentration. So I can change the concentration. I can change the concentration of my reactants or my products, and it's going to shift. So the first thing I could do is I could add something. So say I add A or B. So if I increase A or increase B, the system is going to adjust to remove it. So if I want to remove it, I need to use it up. So if I increase these, I'm going to shift away. So kind of if you add it, you shift away. So that's how you can think about adding. You're going to shift away. So if I shift away, I'm going to make more product. So more product is going to be created, and the reaction shifts forward. So your answer, if I asked you, like if I added A to the reaction, which way does the reaction shift? You would say forward or to the right. Either way. Now, this is the same thing I could say, what if I add C, or what if I add D? If I add a product, it's going to shift away. So then it would shift left. Okay, so just shift it away if you're adding. Because I'm trying to get rid of it. So to get rid of it, I have to go away from it so I can use it. Now, what if I remove A or B? So if I remove A or B, now the system is trying to make more of it because I'm trying to balance it. So if this goes down, okay, so instead of adding, I'm removing. We want to shift towards because I want to make more of it. If I got rid of it, I want more of it, so I'm going to shift towards it. So if I remove some A or B, now I want to create more of it. So more reactant is created, so it's going to shift backward or to the left or reverse. Any of those are fine. Same idea. If I remove C or D, if I remove it, I'm trying to balance this out. So if I remove it, I want to make more of it. So I'm going to shift towards it. So now I'm shifting to the right or forward. Okay? All right, so let's kind of see a diagram of this. So here's my reactant, the cis 2-butene. The trans is my product. I start off with a bunch of cis. I have no product. That's how the reaction starts. The reactant starts going away to make product. I start making the product. It keeps going until it reaches equilibrium. So now right here, this is equilibrium. So now I'm at my equilibrium point. So I'm just chilling at equilibrium. But then half of my cis is removed. I remove some of this guy. So it's at equilibrium and it stays at equilibrium unless something happens. A stressor happens to the system. So this stressor is that I remove cis. So if I remove the cis, this guy goes down. I'm going to shift towards it. So now I need to make more cis. So I'm going to make more cis, which means I have to use up product until I reach my new equilibrium. Okay, so this is what's happening. It's just an adjustment in what that looks like. All right, so let's practice just our concentration part. So for each of the following scenarios, determine whether the equilibrium will shift to the right, shift to the left, or neither. All right, so I'm adding O2. So I find O2, I'm adding this. So if you increase, you want to go away. So if I increase, I want to go away. So if I increase O2, I want to go away. So I'm going to shift to the right. I'm going to go to products. Okay? Because I'm trying to get rid of what I just added. I'm trying to negate it. Balance it out. All right, if I remove H2S, so this goes down. So we said, if we said increase, we go away, decrease, we go towards. Okay, so I decrease this guy. So if I decrease him, I have to go towards him to make more of him. So I'm gonna shift left. I'm gonna go to reactants. I'm gonna make more reactants because I just removed some of the reactants. All right, next one. Let's remove H2O gas. So I remove H2O. If I remove it, I'm gonna shift towards it to make more of it. So now I shift right to products. All right, next one. S. I'm going to add S. All right, now, let's remember when we wrote our equilibriums, when we wrote our KCs and when we wrote our KPs, we didn't include what? We did not include liquids or solids. So if we didn't include them in my reactions, in my equations that I wrote where it's products over reactants, that if this isn't included, then it's not going to matter. Okay? So, solids are not included in my KCKP reactions. So, I could change them all day long and it will make no difference. So, I could increase this, won't make a difference. I could decrease this. So, my answer here is no change. It's not going to go either direction. Okay? These did because this was a gas, this was a gas, this was a gas. So it has to be something I write in my K reaction for it to matter. Okay? So that's if I change the concentration. All right, so next let's talk about if I change volume or if I change the pressure. What does that do? Okay, volume or pressure. So the K does not change if pressure or volume change. So what that means is the number that I find for K, like my mathematical number, doesn't change. So the number itself doesn't change. Okay? But the equilibrium position may change. So the equilibrium position may change. So let's look at this. So let's consider this reaction. I've got N2O for gas and it's going to 2NO2 gas either way. If the volume doubles, what happens to all my concentrations? So let's think about this. This is volume. And in my K's and my KC's, they're concentrations. So what is the units of concentration? Concentration is moles per liter. This is a volume. So if my volume increases, if it goes up by 2, if this goes up by 2, then my concentration is going to divide by 2. It's going to go down by 2. So if the volume doubles, all my concentrations divide by 2. All right, so let's look at this. If I had 5 moles in 1 liter, then that was 5 molar. But now if my volume doubles, now it's 5 moles in 2 liters, now it's 2.5 molar. So my concentration is going to divide by 2. So let's see what happens with the equilibrium. So here's my Kc. It's products, NO2 to the second, over reactants, N2O4. Okay? So that would be my Kc. Now, if everything goes in half, so now my NO2 concentration is going to be in half, my N2O4 concentration is in half, but since this is squared, it's 1/4, 1/2, and then I could just divide this, which is just give you 1/2. Okay? So now my Kc, my Q, is going to be half the Kc. Because when I change the reaction, I'm changing the Q, sorry. When I change the reaction, I change the equilibrium. It's got to find a new place. So it's going to have to shift. Okay? So when I change this Q, my concentrations, now it's going to change the Q. So now my Q is going to be less than the Kc because it's half. So what's going to happen, remember we said if Q is less than Kc, we talked about these, then I want my Q to get bigger. And if I want my Q to get bigger, it has to go towards products. All right, now that's in this case, it's going to go towards products. This isn't like it always goes towards products. It's for this specific reaction. It's going to go towards products. So let's talk about how do we generalize that. All right, so here we said that, here's my reaction, if the volume doubled, I'm going to have a lower concentration, and so I want to minimize that change. So I want to try to increase the concentration. So to minimize it, I want to increase my concentration. So I want to make more molecules. So I want to shift to where I have more molecules. So here's 1 molecule, here's 2. So I want to go towards the side that has more molecules. So I'm going to shift towards the products. Because I'm going to go from 1 molecule to 2. So your general rule, here's my general rule for volume. If volume increases, then you want to go to the most molecules. You want to go to the side that has the most molecules. Now remember, don't count solids or liquids, okay? If the volume decreases, then you go to the least molecules. Okay? All right, so that's volume. You want to go depending on if you're increasing or decreasing. So if I increase volume, you want to go to the side that has the most molecules because you're trying to increase the concentration. All right, let's talk about pressure. What happens with the pressure? So pressure, if we doubled the pressure, now what we want to do is now all my molecules are going to be really close together. So if I double the pressure, I want to decrease this. So the way I want to decrease the pressure is by having less molecules. So I want to remove molecules when my pressure goes up. So I want to go to the side that has less molecules. Okay, so I'm going to shift towards reactants. Because now I want less molecules. So here's my general rule for pressure. If pressure goes up, go to the side, go to the least molecules. Because I want to remove it. If I remove the molecules, then I have less pressure because there's less things creating the pressure. If my pressure goes down, then I want to go to the most molecules. So what you need to see is it's kind of opposite of volume. So volume is up and most, pressure is up, it's least. Okay, so this is kind of tricky because a lot of people start getting them all confused and mixed up and all that. So you need to be consistent and keep it straight. All right, now let's talk about what effect does the pressure and volume have if my number of molecules are 0. Here I've got 1 and 1, and here I've got 2. So I've got 2 on one side, 2 on the other side. Here, since I have the same number of molecules on both sides, my pressure and my volume changes are going to have no effect. Because there's not a side that has more or less molecules. So if the volume increases, so if I increase my volume, we said, what do? Volume increases go to the most molecules. Volume increases, most molecules. I don't know where to go. This has 2, this has 2. So when it's the same and the volume is increased, the system cannot adjust. Because there's the same number of molecules on each side. So I was at equilibrium, I screwed it up by changing the volume, but I'm gonna still be at equilibrium. So if they're the same amount, you just say no change. It's not gonna shift either way. If there's not one side with more molecules, it's not gonna shift one way or another. Okay? All right. Another way that we can kind of change the pressure is instead of increasing the pressure or decreasing it, we could add something in. So we could add in an inert gas. So let's add in an inert. Remember, inert means it doesn't react really. Okay, so we could add in an inert gas. So if we add in an inert gas to change the pressure, it's going to have no effect. Now you might say, wait, you just added stuff and the pressure is going to change. Why not? Let's talk about it. The total pressure does change because I'm just adding more stuff into it, so it's going to change. But my volume does not change. Just adding more stuff, but the volume doesn't change. Nor does the amount of reactants or products because it's inert. It doesn't react. Okay? So the volume doesn't change because I didn't change the volume. I said I just added the gas to the same container it was already, everything else was in. So if I'm just adding a gas, I'm changing pressure, but I'm not changing volume. Nor am I changing how much I have of my reactants or products. So if the reactants moles don't change and the volume doesn't change, then my concentration, which is moles over liters, also do not change. Okay, because remember, moles over liters, this is my concentration. So if my concentrations stay the same, then my pressure of that gas is gonna stay the same. So it doesn't matter. Okay? So if I add in an inert gas, it doesn't change the pressure that that specific gas is feeling, so my reaction is still at equilibrium. It doesn't mess with the equilibrium. Okay? I can add all the inert gases I want, nothing happens. All right, that's if I add a gas. The next thing I could do is I could add a solvent. Okay? So what if I added a solvent? So what if I just added a bunch of water? Okay? I wanted to add a bunch more water or something like that. So the Kc is not changed. Okay? My number in my Kc is not changed. By solvent addition or removal, I can add or I can remove the solvent. But the equilibrium position may change. That's my Q. My Q may change. So let's look at this reaction. I got HSO4 minus, I got some water, H3O plus. Remember, this is a liquid, so it's not here. It's not in my Kc equation. That's why if I change it at all, it doesn't matter. Because it's not in the equation, it doesn't change my number, my Kc number. Okay? But it will change the volume. So if the volume is doubled, okay, so say I add more solvent, I add some more water, so now the volume is doubled. If I increase the volume, so remember moles over liters, if the liters goes up, the concentration goes down because this number's on the bottom. So if this goes up, the whole number itself goes down. So if this goes up by 2, then my concentration is going to go down by 2, half. So my Q is going to be half my Kc. So same thing, if Q is going to be half of my Kc, which way am I going to shift? I need to get bigger, so I'm going to shift to products. Okay? All right, let's do some practice. For each reaction, predict in what direction the equilibrium will shift when the volume of the reaction vessel is decreased. All right, so let's talk about what we're doing in these problems. What's happening? So my volume is decreased. Okay, volume is decreased. So volume goes down. Okay, so let's look at the first one. We said for A, if volume goes down, what do I do? So let's go back. Let's look at our general rule. If volume goes down, I want to go to the least molecules. Okay? Okay, so volume goes down, I want to go to the least molecules. All right, so let's look. A, how many molecules on the left? 1, because it's a gas, it counts. How many on the right? This is a gas, they both count. So 2. So which side has the least number of molecules? The left side. So it's going to shift left, or to reactants. All right, let's do the next one, okay? So I want to go side with the least. So let's look how many molecules I have, okay? So I've got solid here, okay? So do I count the solid? Nope. I got a gas, so I got 3. Here's a solid, don't count it. Here's a gas, it's got 2. So I want to go to the side with the least number of molecules. So that means I'm going to shift right. Oops. To products. All right, let's do C. Here's a gas, so that's 2. Here's a gas, that's 2. I want to shift to the least number of molecules. It's 2 and 2, so that means no shift, or you could say no change. All right, so these should be pretty easy because they're not math. So I really want you to focus on what are my general rules and practice these, because on the test, this should be your easy points here. These should just be knowing what it is. What does it say? Volume up, volume down, pressure up, pressure down. Where do you go? What if I change the concentration? Those kind of things that get those points. All right. The last thing we're going to talk about is temperature, and we'll talk about that on Friday.